Hello everyone, welcome to my channel Chemistry is Fun. Today we will study a new topic, that is liquid state. Now see, liquid state is intermediate between the two states of gas and solid, that is intermediate between gaseous and the solid states. The liquids have fluidity. They have a definite volume but they do not have a definite shape. That is, the intermolecular forces of attraction are intermediate between that of the gaseous state and the solid states. Now, the properties of the liquids can be explained on the basis of a molecular theory, which is the kinetic molecular theory, and it has some postulates like every liquid is made up of molecules, and in some cases it may be made up of atoms as well. In this, the molecules are quite close together, means not as in case of solids, less than that, but compared to gases the molecules are closer together. The intermolecular forces of attraction are larger than in gas, but it will be definitely less than in case of solids. And since the force of attraction is less than that in case of solids, the molecules in liquids can move, so they are in a state of constant rapid motion. The average kinetic energy of the molecules of a liquid is directly proportional to their absolute temperature. So directly proportional means it will vary directly. That is about the average kinetic energy of the molecules. Based on these postulates, we can discuss the properties of the liquids. First, we come to the shape. They are not having any shape of their own. They take the shape of the container in which they are kept. So, we find that they do not have a particular shape. The liquids are mobile, but they cannot expand like gases. Next, we come to volume. They have a definite volume because the molecules are better packed, they are closely packed, and the cohesive forces are stronger. The molecules are not quite free to occupy all the space provided. Next, we see density. The molecules are closely packed, so the density of the liquids is higher than we find in the gaseous state. So definitely the density of water will be more than that of the water vapor under similar conditions. Next, we come to compressibility. The molecules in a liquid are held by strong cohesive forces. So they are more or less relatively incompressible. The volume of any liquid will decrease very little if we increase the pressure. So compared to gases, they are relatively incompressible. Next, we study another property of diffusion. Whenever there are two miscible liquids and we put them together, the molecules of one liquid will move into the another. The space available for the movement for the molecules is less, so their velocities are also small. Therefore, the liquids will diffuse slowly compared to the gases. If we consider evaporation, that is when the liquid changes into vapor state, any moving molecule which is present on the liquid surface definitely has sufficient kinetic energy so that it can overcome the molecular attraction and it will escape out. Means when a molecule in the bulk will be held together by all the molecules surrounding it, but on the surface the kinetic energy available is sufficient for some molecules to overcome the molecular attraction and they can go to the gaseous state. But evaporation will depend upon certain factors. First is the nature of the liquid. Now see, the evaporation depends upon the strength of intermolecular forces, which are the cohesive forces. Therefore, the liquids which have low intermolecular force will evaporate faster compared to those which have high intermolecular forces. That's why we see that alcohol will evaporate more quickly than water, because the intermolecular forces is more in water than in alcohol. So evaporation will be more. Alcohol will evaporate quickly. Next we see surface area. In surface area, evaporation we know is a surface phenomena. So larger the surface area, greater will be the opportunity available to the molecules to escape. So the rate of evaporation increases if we increase the surface area. Then temperature. The rate of evaporation will increase with the increase of temperature because the kinetic energy of the molecules will also increase with the rise of temperature. So we see that rate of evaporation is directly proportional to the temperature, directly proportional. Next, flow of air current. Now over the liquid surface, if there is flow of air, then it will help the molecules to move away from the surface of the liquid. So it creates space for a new molecule to come into that area, thus increasing the evaporation rate. Next we come to a very good new topic, heat of vaporization. It is the quantity of heat which is required to evaporate a particular unit mass of any given liquid at a constant temperature. It will depend upon the strength of intermolecular forces. If the intermolecular forces are high, higher amount of heat or larger quantity of heat will be required. The value of heat of vaporization will decrease with increase in temperature and it will become zero at the critical temperature. So I repeat, value of heat of vaporization generally decreases with the increase in temperature and becomes zero at the critical temperature. Because critical temperature is the highest temperature at which the substance can exist as a liquid. Then we take a look at the vapor pressure. Now see, if we close the area or the space above the liquid, the molecules cannot escape into the open. Like see, if there is a container in which liquid is kept and this total area, this is the container in which liquid is there and we cover it. So the liquid molecules cannot escape out of this area. So these molecules which are inside, they can maximum come here. They will get accommodated in that space provided. So these molecules will strike the walls of the container. And when they strike the walls of the container, they may rebound and again they go and strike the surface of the liquid. Then they get trapped on the surface of the liquid. So what is happening? They are returning back from the vapor state. First they are going to the vapor state, then they come back to the liquid state. So when they return to the liquid state, we call this phenomena as condensation. So first from the surface, they are going to the vapor state, then they are rebounding back and coming back to the liquid state. So we also get the process of condensation here. Now slowly with time, as the evaporation will proceed, the number of molecules which are present in the vapor state, that increases. Naturally, more molecules are going to the vapor state. So as the number of molecules going to the vapor state increases, their tendency to come back to the liquid surface also increases. So the rate of condensation will increase. Slowly we find that after some time, the rate of condensation will become equal to the rate of evaporation. And vapor is in equilibrium with the liquid state at this point slowly. So there is a equilibrium between the liquid state and the vapor state. Equilibrium sets in. Now at this time, the pressure which is exerted by the vapor when it is in equilibrium with the liquid at a given temperature is called the vapor pressure. Mathematically, we can represent this as P equal to N by V into RT. And N by V is the concentration in moles per liter. N by V, concentration, N by V is represented by C, and C is concentration of the vapor in moles per liter. For any temperature, that is at any given temperature, the vapor pressure for different liquids will be different because the cohesive forces are different. If the cohesive forces are high, then it becomes very difficult for the molecules to go to the vapor state. Some of the liquids get vaporized very easily, then they are called as volatile liquids. If we compare the vapor pressure for non-polar and polar liquids, we find that the non-polar liquids will have high vapor pressure because their intermolecular forces are weak, so they can easily go to the vapor state. And the polar molecules, that is the liquids having polar molecules, have lower vapor pressure. Vapor pressure can be measured by barometric method. Now there is an equation also called as Clausius-Clapeyron equation. If we measure the vapor pressure of a given liquid at two different temperatures, then they can be compared with Clausius-Clapeyron equation, which states as, mathematically we can write it as log of P2 by P1, that is the pressure at temperature T2 it will be P2 and at T1 the pressure is P1, then log of P2 by P1 equal to delta H by 2.303 R 1 by T1 minus 1 by T2, where delta H is the latent heat of vaporization, R is molar gas constant. And the actual form for Clausius-Clapeyron equation is log P with base 10 equal to minus delta H vaporization by 2.303 RT plus a constant. If a graph is plotted between log P with base 10 and 1 by T, there will be a straight line but the slope is negative as we see here. And the slope is given by minus delta H vaporization by 2.303 R. So children, I hope you could understand the topic which I discussed today. Thanks for watching my video. Please subscribe to my channel if you have not done it yet. Thanks for watching. Thank you.